Welcome to this video, brought to you by the National Academy of Sciences and Humanities. Today, we explore one of the most pressing challenges of our time, climate change. Specifically, we'll focus on how technology is playing a crucial role in mitigating climate change by reducing emissions and accelerating the transition to a more sustainable future. Climate change is driven primarily by the buildup of greenhouse gases in the atmosphere. Carbon dioxide CO2, methane CH4, and nitrous oxide N2O are some of the key contributors. These gases trap heat from the sun, leading to a rise in global temperatures, disrupted weather patterns, rising sea levels, and the loss of biodiversity. But where do these emissions come from? And how can technology help us tackle this issue? The largest sources of greenhouse gas emissions come from energy production, transportation, industry, and agriculture. Fossil fuels, coal, oil, and natural gas are the primary culprits, accounting for the vast majority of emissions. Yet, this provides us with an opportunity. By embracing technological advancements, we can significantly reduce emissions and shift toward cleaner, more sustainable alternatives. Technology offers a range of solutions for mitigating climate change, from reducing emissions in existing systems to developing entirely new ways of generating energy. Let's take a closer look at how various technologies are contributing to emission reductions. One of the most important contributions of technology to climate change mitigation is the development of renewable energy sources. Solar, wind, hydropower, and geothermal energy are all clean alternatives to fossil fuels. Solar panels, for example, harness the sun's energy and convert it into electricity. Wind turbines capture the power of the wind, while hydropower generates electricity from flowing water. Geothermal energy uses the heat from beneath the Earth's surface. These technologies not only produce energy without emitting greenhouse gases, but also offer an increasingly cost-effective alternative to traditional fossil fuel-based power generation. The global transition to renewable energy is essential for reducing the carbon footprint of electricity generation, which is one of the largest sources of global emissions. While transitioning to renewable energy is a powerful strategy for reducing emissions, the reality is that we still rely heavily on fossil fuels in many sectors, such as industry and transportation. This is where carbon capture and storage (CCS) technologies come into play. CCS involves capturing carbon dioxide emissions from industrial processes or power plants before they are released into the atmosphere. The captured CO2 is then transported and stored underground in geological formations, effectively removing it from the carbon cycle. Though CCS is still in its early stages, it has the potential to play a pivotal role in achieving net zero emissions, especially in industries that are difficult to decarbonize, such as cement production and steel manufacturing. Energy efficiency is another area where technology is making a significant impact. By improving the efficiency of buildings, appliances, vehicles, and industrial processes, we can reduce the amount of energy required to perform everyday tasks. This directly leads to fewer emissions, since less energy consumption often means lower carbon emissions. For example, energy-efficient appliances, such as LED lighting and high-efficiency HVAC systems, can drastically reduce the energy demand of residential and commercial buildings. In the transportation sector, the development of electric vehicles, EVs, is revolutionizing how we move, offering a cleaner, more efficient alternative to traditional gasoline-powered cars. Another innovative solution is the electrification of traditionally fossil fuel-powered systems. By switching from gasoline or diesel-powered vehicles to electric vehicles, EV, and from gas-powered heating systems to electric alternatives, we can reduce emissions significantly, especially if the electricity comes from renewable sources. However, electrification on a large scale requires a more sophisticated energy grid to enter. The concept of smart grids. Smart grids use advanced digital technology to monitor and manage the distribution of electricity more efficiently. They allow for better integration of renewable energy, reduce energy waste, and enable consumers to track and adjust their energy use, further promoting energy efficiency. Bioenergy is another promising technology for mitigating climate change. It involves using organic materials, such as crops or waste, to generate energy. When combined with carbon capture and storage, bioenergy has the potential to achieve negative emissions. This means that bioenergy can absorb more carbon dioxide than it emits during production, offering a way to actively remove CO2 from the atmosphere. In addition, The development of plant-based and lab-grown foods is revolutionizing the food industry, offering sustainable alternatives to meat production. By reducing the environmental impact of agriculture, these technologies contribute to lower emissions from the sector. As individuals, communities, and nations, we must embrace these technologies and work together to ensure that we not only reduce emissions, but also create a world that is resilient, sustainable, and just for future generations. Thank you for watching this video brought to you by the National Academy of Sciences and Humanities. Stay informed, stay engaged, and together, we can be part of the solution.